recap like what we have done yesterday. So NumPy is actually basically numerical Python library. So like basically we use this to do all different kinds of matrix operations and vector operations through this. So in case it is similar to list, just that on top of the list, like if you define it in NumPy array of, and then in bracket, if you write whatever list, it will be converted into NumPy array. So that's what we did here, like define 10, 20, 30, and then so this became an array of like a single dimension array in this case. So, and if you can see the properties, what kind of properties are available. Let me skip this, like go for these things. So if you see argmin, argmax, like we'll see all those like conjugate. So if you see these diagonal, flatten, these are all like matrix related operations. So let's see like few of them now. Okay. So similarly, you can see the shape of your array by doing dot shape. Okay. Similarly, like we tried like two-dimensional array. So where the shape is like 2 by 3 once you try. Okay. So let me similarly three-dimensional array here where you get it like this. Okay. So we tried like max. Okay. Now let's so similarly let's see like what kind of functionality is there in NP. Like okay, now actually what I have done is like I have opened it again, right? Like we close the notebook, so we have to run it from beginning. These things, if you click on A, that doesn't retain a value. If you can see, it comes from number 1. Okay, so what you should do is from beginning, you can restart and run all if you can do. Then it will run everything from the beginning. Like it will start running from 1, 2, 3. It will start. It will start throwing the fresh results over here. See? Okay, it has successfully run till here. Okay, so here what we are trying now is like did dir of numpy like np. So there are like many functionalities. Let's see if something is useful. This we have used this, right? Like numpy np dot array. Similarly, there are like array to string. This like it won't be much useful. So similarly, there are this cos, h, like what we use for in math dot functions. Similarly, those were also incorporated here. So let's go forward. Let's not even use those. Okay, there are like many like this. Let's click and then come start giving some examples which will have those things. Okay. So np dot. In case if you want to create your own matrix randomly or something. So first, like we'll try to create an identity matrix, okay? Of let me do this. Like I'll tell you like what it will have. 2, 3. Okay. Okay. So what does it happen? So it has if you do like np dot ones will create like all or one with like 2, 3. Like it means like shape is 2, 3 actually. Like if you go inside, you can also give it like this so that you'll understand it well. So of shape, you can directly create use this function. These will be very helpful in like future. So you can define some matrix this way. Let me create some more with zeros. That it will be zeros of shape. Let's see, try a different shape. 3, 3. Yeah, you got a 3 by 3 matrix, right? So this is one more thing. So in case we want random values, not like zeros or ones, just like you want to throw a random initial random values, like which is also needed. Let me try some. Okay, identity also. Let's go use identity matrix as well, and then we'll go for random. Let me do 2 by 2. Okay, it's not ice, maybe ice. Let's check in the der, like in case you have a confusion. So it starts with small letter. I, that's what I wrote, right? Np dot I. Oh, it's there. Okay. So, you should not give shape in the sense, because identity matrix usually is a square matrix. So just if you give number, it will give you like this. Like the error initially, like what we tried earlier, what kind of problem did we do? So earlier, like what we tried is I of, and we gave shape equal to 3 by 3, right? So this gave an error saying that I is not got an unexpected keyword shape. So if you see I and then press enter, so you can see these are the keywords which it can take, but there is no shape in it, but we gave shape as a keyword. So that is why we got that error. So we have to just give this number, like only n, not like both. So let's try that. Give a 3. So you got a 3 by 3 identity matrix. Okay. So similarly, one more important thing is, like we have to, there is one good functionality where it can generate random numbers. So that functionality is also available by default by another library called random. But anyway, like we are talking about NumPy, so let's use it here. Both were similar. So there is this np.random. If you go here, so there is a function inside. So let me see like what are available sample. Okay. So if you can see here, I just wrote np.random sample 10, and it started giving us values. So how many are there? 10 values here. So 10 is too big. Like let's do it like 4. You can see it has given 4 values. So it means like it randomly samples, like out of like 0 to 1, it randomly samples how many values you give here, and it will give you as an array. So that's what NumPy random sample will do. So this is like random np.random is like very much useful in our code. Like in ML mostly, like we do randomization in like many scenarios, like while splitting your code, like while extracting data or filling or missing information. There will be like many scenarios such way, like where we do this random sampling. So this is really useful function for us. So similarly, if you want to
No, but
sample from, yeah, yes, Srikanth.
Raju, a sample function you have been used, but where the input is coming from this for?
Input, no, it's like it from 0 to n, 0 to, sorry, like it will pick values from 0 to 1. In between 0 to 1, any value, it can take like any decimal value. It will be in between 0 to 1.
Okay, why only 0 to 1?
No, it is designed this way. If you want for it to be like some other like some 0 to 10, you just make it into 10.
Oh, okay,
Then what
okay,
happens,
okay,
like
okay.
it will be there. So that's why, to make it generic, like it will be sampled between 0 to 1. Then you convert it like depending on your use case. So this is one
Yeah.
way, okay? So, but maybe let us say I have got a string equal to something like some value, some string value. Okay, I just wrote 3 values. Okay, so I want to pick one of them randomly, not like directly. I want the code to choose like one of these randomly. Let's say there are like 10 participants in a show, and you want to write a program to pick one of them randomly. So it's something similar to that. Let us try that. Like in case, how will you do it? Random dot we can't do sample. Okay, sample will only take. Let's do that. Like, will it take? So it won't take. Like, it just needs a number so that it will give those many values here. So what should we do? There is a random dot random. Sorry, just what you should do is, like, in case if you are not very sure, do this there. Okay, then there is a random sample. Okay, let's run this. It's a function a comma 1. Okay, so it takes only one argument. Let me do this. Okay, this just a moment. So actually, this is one more like mostly user function. This is used like only time. Random dot random. Did we try this? A comma 1. Okay, this is also same as sample. I'll let me try once. Like, if I don't get, like, let me do this. So these things, once you do it, like, you won't remember it, right? Like, you will be using that code but not going into that line again and again. So things are like, you will forget uh, the values inside. It's just like, what kind of functionality you use here. You should, even for your case, like, you don't have to remember exactly what function you use and what code you use. Just that you should know that this library will have some functionality like this. That is the only thing you should be remembering. Like, the next case is, anyway you have the Stack Overflow or something, like, where you get the results. So let me also do the same. Choose choice. I guess choice. Yeah. Okay, suddenly I remember. Let me do this. Yeah. So thing is, just now I remember, like, if you have a list, you pass this list here and then choice and then one. One means, like, you choose one amount. So let me create a kind of a list. It can be a string or anything. Okay. So let me create 0 to 100. Okay. I'll also print here. Okay, it has printed. So if you see, I have taken a list of 0 to 100, from 0 till 100. So I want to pick a number, like 10 numbers out of them. Okay. So it has randomly picked those. A kind of housey game we play, right? Like Tombola game. So in that, it's similar. So you pick, like, among those things. So it's something like this. So again, here there is this picking with replacement and picking without means the same number can repeat or same number doesn't shouldn't repeat. There are also options that way, but as of now, let's not go into all those. Like, it's if you want to see, like, there is this Numpy. You go to this Numpy Docs. Okay, so it has, like, all this documentation. Let me go here. Oh, web documentation. You can also download it, but you don't need to download, because this documentation gets updated every time. So for every package, there will be something like API reference and things. Random sampling, yeah. So let me show it here. It's not given like that, is it? Okay. So let me click to the quick search. mm, np dot random sample. This is what we have seen before, right? So it will just give what it will give is like it will explain what this function is, and also gives an example function like what it will do. This is what we tried. Like if you give 5, it gave us like 5 there. Okay. Similarly, like let me tell you like np dot random dot sample. Earlier we gave like 5 and it gave us 5, right? So in case if I give 5 comma 5, it wouldn't take. If you want to give it like this, then you should give within a square bracket. It means that as a shape. So it has given a 5 by 5 matrix. It has generated a random matrix of 5 by 5 shape. So this is also very much required for us. Like mainly I'll use this rather than any other thing. Okay. So this is one thing. And let me do, and as I told, this numpy is more about like matrix operation. Let me also tell you something. So let me define a dot array 1 2 3 4. Let me print it. Okay. Similarly, let me save it in B. So okay, if you want to do matrix multiplication or matrix addition, let's see like how it can be done. So if you do A plus B, you are able to do it. Let me do into B. So in this case, see what happened. Like, is it really multiplying or it's only multiplying element wise? If you see 12 A into B, right? Like A plus B is clear. It has done it as expected, but A multiplied B also, like what it has done, this 6 into 2, it has given us 12, and 3 7 it has 21. So it has done element wise but not the exact matrix multiplication. So matrix multiplication you will be doing like a row with this column and then this row with second column, that way, right? So that is not how it is done. So in case if you want to do it that way, so how we should go for it, like np has this map. Okay, it means like matrix multiplication of a comma b. So if you run it, so this is how you can do, like the value, if you what you will be getting is the matrix, real matrix multiplication. Okay, so you can verify by doing with hand calculation. So similarly, we practice using, instead of a plus b, even for addition you can do this, or subtraction you can do this np dot. Okay, so there is subtraction is slightly different. Subtract. Okay. So one more thing is like in case if you want to know like dot and after that like what functionalities you have. Earlier what we did is did like this and then use it there before, so that it will list down all the functionalities, right? But there is one more way to check how. Let me tell you. So you do np dot and then press tab. So okay, let me do sub. Okay, just a minute. np dot subtract. So after you do sub, like it will automatically, if you press tab, it will automatically give you, it will, in case if there is no other result, so it will automatically make fill the other rest of the words. So in case if there are like few, it will show that list. See, I read SU and then tab, and it has listed on like what different possible things are there. So this is okay. So let me do subtract here and then a and a minus b. You got some values here. Okay. Similarly, Yesterday we were talking about A transpose. Let me also give a quick introduction again on that. So let me take A as the same A what we have earlier. Okay. So to transpose, you do dot T. It has transposed. Okay. But in case if it is like multi-dimensional array, np dot array of okay. Where A is like this. Okay. So if you do A dot T, you get it like this, but maybe this is not what you want. You want something like this 1 4 should come in between and 3 2 5 should come here, like some kind of shuffling you want to do. So such kind of things is also possible. Okay, so for that what you have to do is like means like axis shifting. That is better explained if I put like more into it. Okay, this is just 2 3. If I have like more arrays over there, 7 8 9. Okay, make a copy of it. So just that I made it of added it in one more dimension over there, made it like 3-dimensional array. It's not 3 by 3 is different from the 3-dimensional. So if you see, this itself is a 3 by 3, added one more dimension. So here, so your output will be like this. So like rows are 3, similarly like columns are 3, and 2 that is there in 2 dimensions, 1 dimension and one more dimension here. So that is this 2. Okay, so this is the thing. So let me now try to do transpose. Okay, before that, in case we want to access any of this code, you can do similar to list, like a of 0. Let me see a of 0 what you will get. So a of 0 you get this. So if it is a of 1, you get the second part. Okay, and then if you want to access something inside this, what you should do is a of 0. Let me, you'll be getting the first row, and then again if you want a particular value here, put one more 0. So this is where like for the shape what you have, in case if you want to go inside, if you want to get a particular element, you have to pass this way from like one, like just like how you have a shape, similar kind of indices you can have. So similarly, if you want a row here, okay, uh, let me do a of 1 is like this. Okay, so you, let me say you need something like let me do 0 here. So you got this row. Okay, but I want some only column, like all 3 columns here. So in that case, what you do is put something like this, which means like I'm taking all from starting to end, and keep 0 0 3. Okay, now this is 0, then you got 11. Let me remove this. You got this. Okay, 1 2 2. Okay, you can also try this way. Let me see if it will work. Okay, yeah, now completely, and this is 1. Yeah, so instead of squares, you can also use a kind of comma here. Okay, So, and it will be similar, like first one will denote the first one, second dimension will denote the second one, and third dimension will denote the third one. Okay. So, in this case, uh, first one denotes this matrix or this matrix, let us say. I think that way. So, I want it in like second matrix, which means like zero matrix, first matrix. So I kept one here, and next I want columns, like all the columns here. So 0 to 3, or like you can give like this, it doesn't matter. Okay, and I want it only a first row, means like first column rather than all columns. So I gave it like 0. Okay, let's see. See, it has given 11, 14, 17. If you can see here. So that is the column here. Okay. So similarly, if you want row rather than column, you can do this way. So you got a row. Okay. So this is one way to use get the elements here. So this initially may take time to understand, but this is important, as well as like you will get accustomed like while doing it more. Okay, so just that you remember this is a format to use in case if you want to access the multi-dimensional elements or rows or columns in that. Okay, yeah, this is about like array like slicing. So we're talking about transpose, right? A dot, there is this np dot transpose, and in, let me do this. It's not capital, then it's small. Yes. So if you see dot transpose, and it has transport given some kind of shuffling. Let's see what is the shape of it. B dot shape. So if you see the shape, let me do it somewhere down. So earlier it was like 233, right? So it has changed to 332. So it has reversed the thing. Okay. So this is a one way. Like let me do more shuffling over there. You can see three metrics here. Okay. So and next three are like three rows within each matrix, and the two are the two columns here. So let me try to access one of them just like how we did earlier. So I want to access last column here. So I did like 2. Okay, and then comma. Let me do like all the rows here and all the columns. Let me see this. Okay, so even if you do just 2 or this, like you'll be getting like this. So now I'll add 1 here. So which means I want a 0, 1, 2 in that, like first row here. It will give you this middle row, means 0, 1, 2, first index row here. And then if you want, you don't want row here, like we want a column. So in that case, what you can do is add, like keep the one here. You'll be getting this one. So okay, this is 316. So in case if I do put 2 here, you'll get an error. Why? Because there is at this level, let me, before even this, in the last shape, it was only having 2 here. Okay, but in case you, it means like 0 and 1. Shape is like 2, which is 0 and 1. In case if you put 2 here, it means like it will go out of index. So that's why it will be throwing this index error. Okay. So, and actually these are mentioned as axes, axis 0, axis 1, axis 2. So if you can also see here out of bound for axis 2. So this is how this is denoted. Okay. So like you'll be knowing while working on it. Okay. Don't worry in case you don't understand. So let me create some different shapes, like instead of same, like let's try doing some slightly different one so that it will be easy to identify which axis it is operating. So I'll take this in. Okay, so I'll add like few more things here. Let me add bigger numbers. Okay, sorry. Yeah, what did we do here? So let me do shape here. So it's like 2, 3, 4. There are like two matrices and then 3 rows for each matrix and 4 columns at for same matrix. Okay, so this is it. So let me do transpose now. Okay, so np dot transpose of A. It is now. Let me take it in B and C. So it would have reverse. So it would be here. Okay, so B dot shape. If you see, it from 2, 3, 4. Now it is 4, 3, 2. It's just reverse the thing. So, but I want it to be like 2, 4, 3, something like that. Okay, I want only 2 axes to exchange, but means like 2, let it remain same. It should be 4, 3. So something like that in case if I want, how should I do it? So let me do that. Okay, np dot transpose A, comma. There is this column, one more argument where you can give how you want the access to be. Okay, I want it like earlier it should be 0, 1, 2, right? Which means this is the order exactly. Now I want to make it 2 and 1. Means the last two I want to exchange rather than exchanging everything else. So let me store it in B and put B here to present. Okay, the access is slightly different. Let me see what is there inside those argument. Name would be slightly different, I guess. So yeah, not this access. Name is slightly different, so we got that error. Okay, so now it has run, right? You can see what. Let's also see the shape. So it's like 4, 3 instead of 3, 4. So what basically it has happened? Can you see here? So these two metrics are untouched. 1, 2, 3. So same were there. Just that this matrix is transposed separately. This matrix is transposed separately. So let me go there and show actual one. So this is the actual one. So in this, like this is transposed where the rows became column, column became rows. Similarly, this is transposed, rows became column, column became rows. So this is also very useful command which we use in ML. Okay, so this is one thing. So the rest all are like same, just that like these are the main matrix multiplication of matrix multiplication and then addition and this transpose and the generating numbers, and we also spoke about how to access some a row or column or like element from there. So this is what is mainly about any matrix, right? So we cover like most of topics in matrix. So there are like many different other functionalities within NumPy other than this. In case we can see this documentation. So okay, so there are like all these operations which you can do. Let me like, but this are not required at this moment. Only in case if you need that particular thing, just that you have to go there. Okay, let me talk about this. something like dot product and inner product. Like these are like some things which you may use, but it is again similar to matrix multiplication. You will be using those like while you can implement through matrix multiplication. So you won't be using it. Let me go for this norm, which is eigenvalues. But actually, these need some math like background where you know linear algebra so that we can use those. So without those, like in case if I tell like you won't be knowing the functionality, but anyway, like for machine learning, I'll be teaching you some basic linear algebra and things like which is needed for ML. So at that time I can show you those. Even if I show you those now, like you won't be knowing the significance of it. So, okay. So that was the case. So till here, are you able to follow or like is there any confusion?
No, it's clear.
It's clear, right? Okay. How about others? Rashid?
Clear. Yeah, it's clear.
Clear. Okay. Okay, fine. Yeah, then cool. If this is clear, then it will be pretty easy going forward. So because everything we try to, yeah, let me tell like one small thing. So in case if you have a list, like we were doing this np dot array on top of it and making it as a number array. Let us say I have a list, okay? Okay, so the next thing is you can use np dot as array as an array, and then if you do a, so it will also become a list, like whatever list, if you, in case if you want to convert it into numpy array, so you can use np dot as array, and in bracket you put that list, it will become a numpy array. Then as array, no need as array, then this will also become that. So but usually just for our convenience to see that like you are converting it into numpy array, you use this as array for that. Okay, so let me let just like in list we have this append option in list, right? So similarly, how we are going to concatenate two different arrays. I missed this topic. I just remembered now. Okay, so let us say you have this a, and similarly, let me make it an array, np dot array. Okay, so b equal to np dot array. Okay, now thing is I want to add these two arrays. Okay, so will this how we can do is np dot append. So let me initially, without trying that, let me do np a dot append, just like how we do for list, and then put b. See what will happen. So it is saying like it doesn't have an attribute np. So how we should be doing this? Np dot append, and then you put a comma b. So when this one, let's see. So position requires one missing argument. Let me do this. Okay. So a comma b, if you put like it is adding here, okay. But in some case you don't. Now we have seen this multi-dimensional array, right? So similarly, let's say I want this in one row and the second one in another row. Instead of adding it in same one long, I want it like 1 2 3 4, and then the next one is like 4 5 5 6 7 8, something like that. Okay. Okay, so something like this if you want, like how we can do. Okay, so how we can do, let's go for that. So we call it like stacking. So where we do it like hit stack, and we stack, let me comma b. It is like same. So if you do v stack, it came like this. So there is a difference between these two, right? So H stack will add by side, okay? So and V stack will, it's like stacking. It will add it in another dimension. If you can see, let me save it as C and this as D. You can also print it. And you find a major difference while try to append multi-dimensional arrays, just like previous one. So C dot shape, if you can see, this is just one stretch 8. But if you see, means it is adding, those dimensions are getting added up. But if you see D dot shape, it is 2 comma. So it means like those are getting added one to each other. Previously it is just one row. So now it became 2 rows. First row has like first matrix and second row is a second matrix. So this is a one way. Like let's try to do this stacking for a larger matrix, like bigger. So let's generate one. This time let's use random to generate. Instead of me adding 1, 2, 3, 4 here, let me use random because we'll get habituated. So okay, np dot random random, and then keep whatever value. It should be sample. Let's also see random. It will be fine. So 2 comma 3. Yes. So it has, see, it has given a 2 by 2 matrix. Similarly, b equal to. So let me again give this. Okay. So it has given one more matrix. So now you want to do the same concatenation like how we have done earlier. So let me do np dot h stack and see where how it will a comma b. See what it has happened. C equal to, let me put the shape as well. So let me also print shape here. Okay, let me print shape as well here. Similarly here. So if you see, previously it is 2 comma 3. It is 2 comma 3, and you are trying to do H stack. So in that case, what is happening is like it's joining those two. Like so, those rows did not change, only the columns changed. So similarly, when if you see above, so the row remained same, right? It is single row, but the column changed. Okay, same thing happened here. So let me see one more thing. D equal to just V stack. Let's do the V stack thing here. Okay, so now there is a difference. So what did it do? So earlier like 2 by 3, 2, 3, 2, 3 matrix. Now what it has happened? It became 4, 3. So it has added rows, but the columns remain same. Okay, this is the difference between H stack and V stack. Okay, just now you may have got the clarity. So finally, let's experiment on a 3 dimension and then leave it. Okay, so again, let me put a as some value here. What I'll do is I'll copy all these things. I'll show the flexibility of Jupyter Notebook. So I have copied it. I've selected all 4, and then I let me paste it here. So if you see, it has pasted like whatever we did here, right? It is pasted here again. Okay. So with the outputs as well. So now let me add like one more dimension here. There's 4, one more 4. And now let's see how we are stacking. So here it is 2, 3, 4 this time. and this as well is 2, 3, 4. Let's see how the stacking happens. So okay, so if you can see here, so 2, 3, 4, 2, 3, 4, and then when you do horizontal stacking, so it became only this at like number of columns has increased. Or what did it increase? The second, this element has increased, right? And similarly, if you see here, this has added it one more dimension. Okay, so this has added in a new dimension, and in the previous case, it increases like this thing. So can you observe like what difference did it? Are you able to observe the difference here? So previously it is like 2, 3, 2, 2, 3, 2, 3, and it became like 4, 3 for VStack. Now again same thing, it became 4, 3, 4. Previously it's just 4, 3 for 2 dimension. It became 4, 3, 4. The last dimension is untouched in case of VStack. So and here in this case means like only first dimension has changed. If you take HStack, the first dimension remained same because 2, 3 and it is like 2, 3, 4 and 2, 3, 4. So it became this like 2 remained same, and in the second dimension, second axis has increased. So this is the difference between these two. Okay. So it like depending on our use case, like what we needed, like we'll use mostly we use like VStack rather than any other things, because like we want only the other, these things remain unchanged, only one first outer dimension to change. So mostly our use cases will be revolving around this VStack. So if you can understand this well, it would be good. Okay, you can
For
try.
VStack,
Mhm.
for VStack, number of columns should be same, right? Whereas for HStack, number of rows should be same.
No, no, it's like rows and columns will come only if you have 2 dimensions. So if you have 3
Yeah,
dimensions, what will you think as row? So that's why that talk in terms of axis, axis 0,
yeah.
axis 1, axis 2. So in like the outer 0 axis will get impacted if you use VStack. The axis 1 will get impacted where you have HStack. So think it that way. Because if
Okay.
it is like
So
earlier
any
example, it is like in 2 by 3 matrix. So we talk in terms of like rows and columns. So it is very clear, but you should be talking in terms of axis 0, axis 1. Then it will be clear. See, like HStack, axis 1 has changed, but VStack axis 0 has changed. So even if there is axis 3, 4, 5, like that won't get changed. Only these get impacted. So means like that is what.
axis one is column rows, right?
No, that's what you don't talk in terms of rows. So this is axis 0. Okay, this is
Okay.
this entire thing is axis 1. Let me do that. D of 0. See this, right? So Z of 1. Similarly, there are like 4 axes here. So you can see D dot shape. First one is like 4. It means like it has 4 in axis 0. I mean axis 0 is these things. Okay, let me put everything here. Let me put 0, comma 0. So you, whatever this is there, na, this is uh, first element of each axis. So this one, this one,
Yeah.
this one, and this one. Okay.
Yeah. So now for this alone, if I'm doing VStack, the
Mm-hmm.
last two axes will go and go beside of first two axes, right? Can you do VStack for that?
We stack for this, right? Okay, let me save it. Okay, good example. It would be here this way. So e dot shape. Let me do this. Also print e. Okay, so this is the thing. So I want to restack now. Instead, earlier we have stacked all the same shape things. Like now we are stacking something of a different shape. Okay. Now will it accept first of all? That is also a question. Let's see. So where is it? Restack. So will it work? Let's see that first. Okay. Let me make it F and like already there is D available. I want to do stack with E. So it said that like all the arrays should be of same dimension. Okay, this
Index.
is an issue. It's because
Yeah.
so in case if you want to stack this, like let's say ignore this part, like this can be anything, but these two should be similar. So some matrix of at least like 3 4 can be stacked. So let me generate a 3 4 random one and then try to, in that case what you should do is random dot sam or random dot random. So let me do this and wrap it up. I know time is getting here. So what you should do is make it like one dimension over there. Okay, and so let us say this one. Okay, so let me try to stack this. So if you can see, it has added one more layer. So which was previously 434. Now this one is added. It became 534, and it has added in the end. Okay.
Yeah.
Okay. Okay. Then I think